Hey guys, sorry about the separate videos. I didn't get a chance to really get to this in the last video, but we're going to work on some example problems in this one. We're going to do examples 1, 2, and 3. And then I'm going to also do examples 10, 11, 12, and then I want you to work on the other problems on your own to see if you guys can't solve them. So a couple things that we need to talk about in the second set, but let's just show how the hinge theorem really applies in these first three. So in the first three, what I'm asked to do is I'm given a set of values. So in this case, we have measure of angle 1, and we have measure of angle 2, and I'm asked to compare their measures. So the first thing I want to do is I want to identify where are angle 1 and where are angle 2 in this diagram. Well, here's angle 1, and here's angle 2. Next thing I want to look at is, can I even apply my hinge theorem? Well, in order for me to do so, right, angle 1 and angle 2 in this case have to kind of be the angles that are in between the sets of congruent sides. Well, for so far, all I have for congruent sides is this one and this one, AB and AD. So where's my second congruent sides? Well, again, remember, we are going to apply the reflexive property, and AC is congruent to itself since it's the side that they share. All right, so these two triangles are going to have those sides congruent. Now, keep in mind, measure of angle 1 and measure of angle 2 are not the same, and the reason why is because this has the side opposite angle 1 has a measure of 10, and the side opposite angle 2 has a measure of 7. Meaning that since the side that's opposite, since the angle is opposite angle, the angle opposite the side length of 10 has got to be more open than the angle opposite side, opposite the side of the 7. Okay, so in this case, we would say that measure of angle 1 is greater than the measure of angle 2. For number 2, again, we're asked to compare measure of angle 1, measure of angle 2. We're going to identify, well, here's angle 1, right, and then here's angle 2. Now, in order for me to apply the hinge theorem, again, I have to have these two angles be between the sides that are congruent. So the first thing I want to do is identify where are my congruent sides. We'll see that we have EH and HG both have a measure of 5, so they are going to be congruent. The second set of congruent sides is, again, our good old friend, or our good old trick, the side that's shared between the two triangles. So since FH is shared, so now we can apply our hinge theorem, and since we were trying to figure out which angle is greater, angle 1 or angle 2, well, we need to look at the opposite sides. The side opposite angle 1 is 8, and the side opposite angle 2 is 7. So since measure of angle 1 opens up to a greater side than measure of angle 2, we know that it is bigger. So again, measure of angle 1 is greater than the measure of angle 2. Then for for number 3, we're going to compare the sides. So first things first, when we're comparing sides, and if I'm going to say greater than or less than, I'm not going to use the little hats, okay? Because remember, those are talking about shapes, and we're kind of talking about measures in here. Measures can be greater, shapes can't be greater. Because how do I say something like, I don't know, table is greater than chair? I mean, you immediately think about their size, but that statement in and of itself is not actually true, okay? So again, I want to identify, okay, where's XB and where's ZB? Well, this is XB, this is BZ. Now I need to have those sets of congruent sides, so we already know that YZ is congruent to XY. So I need my second set of congruent sides, which of course, again, shared side. And so now I can apply the hinge theorem. So what I'm trying to figure out is XB greater than BZ, or is BZ greater than XB? Well, again, I'm going to look at their angle measures. Since the angle opposite XB is 24 and the angle opposite BZ is 26, right, since BZ should be open a little bit more because the angle is open a little bit more. So in this case, I would actually say that BZ, or ZB rather, is greater than XB. So ZB, in this case, is greater, measure of ZB is greater than the measure of XB. That's how we can apply the hinge theorem in simple cases. We can also use the hinge theorem, right? We can also use the hinge theorem in order to find possible values of lengths or variables and possible values of sides. Okay, so in this case, a couple of things that we need to make note of here, though, is where these three problems you have to apply them in a very concept base. So just setting up is actually a lot more complicated, because some things that you have to keep in mind is that angle measures have to be, in a triangle, have to be less than 180 degrees but greater than 0. They can't be negative. Side lengths, right? Sides must be greater than 0. Now they can have infinitely large. There's no real cap on sides. But as long as I can remember and apply these kind of ideas at the same time that I apply my hinge theorem, right, we can actually solve for possible values of x or possible side lengths or possible angle measures. So in this case, the first thing I want to do is I want to identify, okay, so what's it asking me to find? I know in this one it's hard to see, but the angles that we're kind of asked to compare are this angle, right, and this angle. And they're going to correspond because if I list out my congruent sides, that side's congruent to that side, and that side's congruent to that side. So those are the two angles that are in between. Now, in order to set up an equation or an inequality using either of these, I need to apply the hinge theorem. Okay, so since 12, and we'll use green for this, since 12 is greater than 8, my third sides, right? Since 12 is greater than 8, that tells me, right, that 102 has got to be greater than 7x plus 4. Okay, we're also going to set up, since I know that this is my smallest angle, since x is going to be my smallest angle, I also know that 7x plus 4 has got to be greater than 0. Okay, again, applying this whole idea of 180, or angles are between 180 and 0. So, again, I could have written this as a compound inequality and said that, but it's just easier for the setup to solve it as 2. Okay. So what I'm going to do is I'm going to solve both of the equations, and I'm going to get a range of values for x. So I'm going to subtract 4 here, subtract 4 here, and I get 98 is greater than 7x. Right? And I'm going to divide by 7, and then x, I think that's 14, but yes, it's 14. So 14 is greater than x, which means x can't possibly be greater than 14. And then I'm going to subtract 4, I get 7x is greater than negative 4, divide by 7, I get x is greater than negative 4 over 7. So those are the two inequalities that I have for this angle. I know it has to be greater than 0, but less than 102. Now please keep in mind that since 102 is less than 180, it already satisfies the first half of this, okay? So now I can put my inequalities together. Since 14 is greater than x and x is greater than negative 4 over 7, that tells me that x is between negative 14 and negative 4 over 7. So even though x can be negative, right, that's going to not allow my angle to be. Okay. Next one. So now we're dealing with, so x is now appealing to side lengths, but some couple things that we need to see here is that these three sides are congruent, as well as these two sides are congruent. Essentially, all four of these different lengths are congruent. However, this last one is not, and the reason why is because this angle, all of the angles in here, is a 60 degrees because this is an equilateral triangle. We notice that all three of my sides are congruent, so it must be equilateral. So if that's 60, right, and that's 45, which one is greater? Well, clearly 60 opens up to a greater side, right, than 45 does. So by the hinge theorem, we can make the statement that, here I'll use, let's go orange, I think. Yeah, we'll use orange. Okay, so that gives the statement that x plus 5 has got to be greater than 3x minus 7. Okay. Also, since 3x minus 7 is the smallest side, right, so we know x plus 5 is going to be greater than 0, but 3x minus 7 also has to be greater than 0, because again, all sides must be greater than 0. They don't really have a cap on how high they have to be, but they do have a cap on how low they can be. Okay? So once again, I'm going to solve each equation. So I'm going to add 7, I get 12, or x plus 12 is greater than 3x, minus x, 12 is greater than 2x, divide by 2, and I have 6 is greater than x. Now I've got to solve the other inequality. I'm going to add 7, and I get 3x is greater than 7, divide by 3, and I get x is greater than 7/3. So x now has to be greater than 7/3, but less than 6, which means that for my solution, x is between 6 and 7/3. Moving on to the last one, going to be a very similar idea. first thing I want to do is I want to identify my congruent sides. I've got this side is congruent to this side, and I've got this side is congruent. Okay. Now noticing that this angle is greater than this angle, we know that this side has got to be greater than this side. Okay, so it's again, since we're dealing with sides, we don't have to worry about the 180. We just know that it has to be greater than 0. So again, we're going to set up two inequalities, or sorry, since this 3x minus 2 is going to be has to be greater than 10 in this case. All right, we already know that 3x minus 2 has got to be greater than 0. So x can be basically anything at this point. So in this case, there's only one inequality that I have to solve. So I'm going to add 2 here. I'm going to add 2. I get 3x is greater than 12 divided by 3, and I get x just has to be greater than 4. Now, if, for instance, I knew what this third side is, so if I knew what this side is, because again, we don't know what it is, we just know that they share it. If I knew what this third side is, and there's ways to kind of tell, but we kind of need trig to kind of get there, then I would actually have a cap on how big this has to be, otherwise I couldn't have a triangle. Again, triangle inequality. So since the case that we don't have any more information, we don't know what this side length is, right, we actually can't set up any more inequalities. So you can see how if we actually know more, the problem does get a little bit more complicated. But in the case that we have, since this side is also essentially variable, right, this x greater than 4 is the only stipulation that we need. Okay. Anyway, so that's kind of how we can apply the triangle inequality. Just remember, again, this right here is gonna be absolutely key when you're working on the future problems for this. If you have any questions, please feel free to email me. You can also, if you'd like to see or check your solutions, you can. Again, just simply send me an email and I will send those solutions to you. Okay. Thanks, guys. Good luck on the assignment, and also have a great winter break.